but cool. Let's take a look. Design a skip list without using any built-in libraries. Let me send a link. Alright, cool. 1206, design skip list. Design a skip list without using any built-in libraries. A skip list is a data structure that takes log n time to add, erase, and search. Compared with Treep and a WebWatcher, which has the same function performance, the code length of a skip list can be comparatively short, and the idea behind skip lists are just simple linked lists. You can see that there are many layers in the skip list. Each layer is a sorted linked list. With the help of the top layer, add search can be faster for n, improving the average time complexity of log n and the space complexity of n. To be specific, you should design search, add, and erase. Erase is tricky, actually. Don't think I've done erase before. And we just have to implement it. We don't have to worry about the complexity per se. I mean, like, we don't have to do rebalancing a skip list, which is, well, I think not anyway. I could be wrong. Because if it is, then it is like way harder. Cool. Yeah. So, what is the way to do it? I forgot the exact algorithm. What is this conf thing? So I'm like waiting for the animation to update so I could see what's going on. New element 45, tail, yay, okay. Config, tail insert element is finished. What? New element 80. Is this search? This animated GIF is very weird. So you insert it there, insert an element into the, oh yeah, and then you keep on inserting. Do you always add a tail? Oh, that's what, so now I realize what it's saying. It's not tail of the list, it's that you flip a coin, it's a tail, so, or heads, I forget which one it is, and you insert to the level on top. Alright. I mean, this is doable. It's annoying, but cool. How do you insert into a given level? I guess you just keep track of the search and then the last element. Yeah, okay, fine. Okay. So let's just say so that level elements, level 2 elements. Naming is hard. Let's just make it a collections.default of. I guess we really do need linked lists for this, right? Because I mean, you could do other stuff, but then like, what was I gonna say? But then like you get terrible performance as a result. I wish there was a linked list class actually, but that's another story. Okay, let's just have a node, a linked list node. Where's in a node? Let's just say value, and then let's just set the next is equal to none. Okay, I guess that's all you need for a node. And self.levels, this is also very straightforward. And do I want to root? Yeah, maybe I do want. No, it's okay. Fine. We'll play around with this. This is not final. So let's just do the add How do these, is it literally just a linked list? So then you can't even keep an, okay, so now I'm thinking about how to keep track of the different nodes on different levels. Do I just, or rather, like, now I'm thinking whether I need or should need um, an explicit pointer or some kind of implicit thing. It's definitely as part of the search. Like you could get them as part of the search, but no, you have to be able to go down. So you definitely need a thing to the node level. So let's just go next. That's part of regular linked list stuff, and then down level. Maybe you need up to, but I think maybe we could do something with stack that cares about it. But yeah, search. So okay. So search, we take the highest level. What happens if, like, say we want to search for 20? How this is kind of a not complete example. I don't remember the edge cases. That's why I'm looking at this a little bit in the sense that like is it do you always put the first node in the list, or is that just like lucky, quote unquote? Let's look at this Wikipedia. I think this is the thing that they don't tell you really. No, they used to. They kind of reused Wikipedia's thing, which is kind of dubious, but okay. Like, is this coincidence that the first one, or is it not? Well, now this is just tell you how to do it, but indexable skip list. Yeah, I mean, I know that. Boom filter is also fun to implement, by the way. I just saw boom filter, also a thing that once you've done it once, you don't forget. So I said this, and I'm forgetting about the skip list. So a search. This part is a little annoying. I just don't know the specs for a skip list, and it's not really in here for whatever reason. Well, I guess it doesn't really matter except for some edge case performance things. But I guess I could also keep track of. Yeah, okay. Maybe I'll just combine these. Instead of assembling this, a node would be. And I could say collections. Is that default of node? Is that good? Yeah, why not? Okay, fine. And then now add I guess what people were saying is you could, I guess, just like add a negative infinity root node And it depends on how kind of like generic you want to be. Because for 20,000, what's 20,000? 2 to the 15 is like too small. 32K. 2 to the 16 is 32K. Or 64K. 2 to the... I need more sleep these days. Alright, 2 to 16, 65K. Let's just use 16. Also because it's fun. We can... Yeah, let's just do self.add... what is it? Negative infinity. And yeah. Now we need a helper because we want to full level, and then just do say 16, which is max. In theory, we'll put these as constant somewhere, and if I guess it's not that rare that you may get more than 16, but let's just say we don't have to worry about more than 16, because it's one in like 120,000 gets more than 16, which given 20,000, that means every like 6 test case of max test case, you would have one element of more than 16 levels, but that's fine. But now that we have that, what does add look like? Okay, so well, we need to add. So we'll just do coin flips until we're right. I don't remember how to do random. It's like random.rand int or something like that in Python. Yeah. Right. Sorry, googling that part. And could so I was right, but they are inclusive, which I don't remember if I knew. While this is equal to 0, which is not possible. Let's do this. Or let's just say 1 for promotion. Let's just do level 1. Can we? I mean, you could actually do this in one thing and then just take the bot. Okay, fine. That is way too fancy. But let's just get a random int from 1 to 32, and then levels is equal to the number of rightmost bits. Is that too hardcore? Or is that not necessary? I mean, so then let's just say, and while n r minus 1 is greater than 0, then level 1. Am I doing this right? I think it's okay. No. Cool. And then we just, let's say level is equal to min of level in 16, or self.max level, maybe, just for double checking. And then now we can do self.add for level, the number, and then max level. And then now we should actually implement it. So still using Python 2 method decorations, but I guess now, do I even need this level? Yeah, maybe. Well, let's actually initialize. Maybe instead of calling the helper. Because then we can make the helper not assume. Okay, fine. For level in sub that max level in the range of this anyway. Sub that levels level is equal to. No, I guess we don't need this. It's just sub that root is equal to this new node with negative infinity and this max level. I guess we could actually put this into the node itself. And then we can, instead of using this, we have sub.next is equal to, it's just none times level, something like that. This is also no longer true. By level. Yeah, because is that good enough? Yeah, I guess so, because you're not getting promoted. Just like life. Okay. And then now we start at the top from the root. So let's say node is equal to self.root. We start at the top of level, and then we just we need to stop at the top so that we get that log n performance. So okay, and then now we go down. Anyway, that sounds like a song, but okay. If no dot value is now we're trying to go with every node. What is the next node that it tries to go to the right as it can? So okay, if no dot so at the root these will be obviously smaller, but okay. But if this is smaller than the current value, which it should, then edge cases, no dot value is less than the value, then we try to go to the right of the current node or next of the current node at the current level. So we have to do some bound checking first. If current level is, so this, at least for the first couple, it should be always true. Len of node.next, and this is not none, then node is equal to node.next current level, and then we keep going. Let's say while, oops, fingering in the wrong place. So while this data is true, you keep going right, and then now we can go down. Will this ever be big? It's true. Oh, I forgot a case, and node dot value is not wow, and this is not none, so we actually don't need this. And then now, when that's true, then we could go down one level. Yeah, and then just while current level is greater, maybe just strictly greater than 0, because once it's at C, no, that's okay. I think at 0 you still want to traverse through, right? I think one of my what I don't like about doing these problems necessarily, at least for learning purposes, is that debugging is kind of hard. But oh wait, there's the debuggers. But in theory, there's a debugger, so maybe we could take advantage of that. But yeah, so add for level. So this should be done. Oh no, wait, we don't actually add. No, so we don't want to go all the way down to 0. So we just go to the level. Maybe even this current level is too small then. Okay, now that we're at the current level, you still want to go all the way down. It's just that we now have to current level is equal to level, just to be clear. And now this is the biggest node to the point in which we can add to the right. So then we just use node dot next of current level is equal to this current node, which I guess we didn't declare the node yet. New node is equal to node of the value, and the level is just the input level. Yeah, new node, and now we want to. So that's at the top. Actually, I guess we could incorporate part of this and then make this part of 0. This is a little bit off. I think I have it off by 1. These data structure things are always weird. So we want to get the previous such that this is not the case. And also, this is not enough because node dot next may be something else. So we need to do all the fun linked list stuff. I mean, design Skiplist, it's just implementing Skiplist. But so okay, so if node dot next current level that row is already not none, but it's still less than row, then we go. Okay, fine. And then now, if current level is less than the input level, then that node we want to do this, but not actually. Well, you have to add something like okay, previous or old node is equal to node dot next current level. So you do this, and then now new node dot next current level is equal to old node. Okay. Really not confident, and also I wish I could just print out like the thing for kind of research. But we could do that. We could write a helper method. Let's just set this to pass and pass. Though essentially I did the search. I mean, that's it. Maybe I could refactor this, but yeah. All right, let's just do a helper print for real quick. What's it called? Okay, for in range of self.max level. Node is equal to self.root. Let's start there. While node is not none, node equals node dot next of oh, why did I do that? Next dot level. But print along the way. Let's just print. Let's print level, and then print node.value. Maybe I could. If I'm better at Python, I should actually convert this into what you call it. I should convert this into an iterator. So, okay, let's do that, and then let's, for now, let's print it out after every kind of I think this is auto, but I'm always not confident about it. Just kind of, and this is where TDD is really handy if you're into. I thought I fixed that because I keep on seeing it, but 37. I don't know how to check, but I guess I had to check here. How would the node not have? Actually, now I should check it out. Maybe I have an off by one somewhere. It's okay. I mean, I hope everyone's learning, right? Something like that. Oh yeah, I think I start at 60 at the max level instead of max level -1, because I've been using the inconsistent in places. Okay. 40 was 40. Oh, it's this. Okay, let's just run the code again, see if it actually crash. Okay, so it doesn't actually print anything before. Oh, because the test case does a lot of funky stuff. Okay, let me put that somewhere else for now. Let me put in a text file, and then now let's make this slightly straightforward. And then because we have some randomization, let's print that out for debugging. Because level is kind of randomly decided. It doesn't print anything before that? Oh, because I've added levels before. Alright, let's just also print before and then... okay. But I really should do this in a faster manner. Wow, this has been half an hour in general. But it is good for learning. I'm learning a bit. So 112, we had the number 1 at level 12. So what's failing about that? Yeah, I have an off by 1 at the levels again. That's fine. Well, it's not great, but there's an easy fix. What is this? Okay. Because level could be 0, but you actually want it to have 1 level at least. Or like 0 being the base level. That's accepted because it doesn't do anything. Okay. What is all this output? Okay, 1, 6, and then at 0, at 1, 2, 3, 4, all the way to... Oh, wow. That's a very lucky roll that we rolled 16 for the first time. I was like, why is everyone, why is it added everywhere? But, okay, so that seems correct. I don't know about performance. Let's see if this is right. This is right on these things, though. I must be doing my math. I think I did it. My counting is off. That's right. I counted the number of ones, but not the number of bits. I mean number of trailing bits. So that's why this is always weird. Okay. Actually, what I want to do is this. Okay. Okay, so 1 is 0 because it's just unlucky. That's fair. 2 gets 1, which half the time, which just makes sense. 3 gets 0 again. I mean, okay. Still wish it was a... But I mean, we saw in other cases that it was okay. Okay, cool. I mean, I feel happy about that. Kind of. I mean, why not? I'm happy in general. Happy person. Okay, cool. Okay, search. Search, we just basically do the same thing here. Just without this part. So maybe it's copy. I think there's probably some abstraction we can do, but I will think about that another time. Also, if you're doing an interview, don't say that. But okay, what does search return? Oh, just true false. Okay. The node keeps on going node, and then now after that we can just check if node.next, because this terminates the one right before val, and also the also I do need the thing, the current level one, and then now let's bring the test case back, but without the removal. No, you know what? Let's run the removal and see what happens. I mean, it will fail the removal, but the other stuff should be okay, except for the last piece. So let's see if it adhere to what we expect it to be. Minus compiling issues. Also target. That's the word. Yep. Level well, yeah. None type has no. It also goes until there's none on the next. Okay, let's do. And then next time. It's not none, and okay, that's fair. Oh, I mean that is. I guess you could simulate it, but I thought you mean you actually would do it, but that's wonky. So I mean, this is the only change. That must be the thing. Um, but how did I do it here? Can this? Did this just never trigger? Because I don't see how this terminates. If no dot. Oh, I guess it. Well, if this is true, but this is false, then it never terminates. So okay, else break. Huh. Sometimes you're just a bit lucky in a weird way. Because actually, I want this to be. This should be part of the while loop, actually, but it's just that I thought it would be too much. It's like an 8-line while loop. Or 8-statement while loop. But that's probably made more sense. Okay, fine. Let's get that in there then. Also, code repeating, not great. But okay, let's see if this. I mean, it's not going to be the right answer because even if it's the right answer, that means we did something else wrong because that would not be what we expect. But let's see if we get it right in the good place. So this should be good. Returns false, so it's not. Oh, I didn't know you're supposed to return on erase. Okay, that's fine though. And then false, so we should at least get this part right and this part right. So what's that? 1, 2, 3. False. No. True. Okay. Anyway, so that's nothing. And then search again. It's false. Oh, well, false again. But the search for 1 is true, which is actually what we expect, right? So that's good in that that's wrong. That's wrong in the way that we expect to be because 1 was not erased because we didn't implement erased. Okay. So that's good. Cool. Cool. Yeah, let's implement erase. Same-ish logic here, I think. This while loop, I mean, I think I'm really tired today, which is an excuse for being lazy. But this is why, when you work, don't overwork because then you end up doing lazy things that you regret in the future. In terms of coding, I mean. Maybe it applies to other parts of life as well, but anyway. Anywho. So how do we remove stuff? Okay, so it's essentially like a search, except for when this thing triggers, we want to go, okay, remove this, you go to force, and then this, oops, removed, and then, well, let's just set remove this, you go to true, and then now we actually want to remove it. We want to so node dot next, the current level is equal to no. Oh, oops. Yeah, that's right. Dot next dot current level dot next. Oh, this is a mouthful. But this is other than the mouthful, is standard linked list stuff. And we don't move the node. Okay, maybe that's okay. Let's see how that goes. Fingers crossed. Pressed it. Oh. And why do they have different parameters for every one of these? Because they keep on calling it different. Like, that is not a consistent thing, maybe. Okay. I mean, I definitely don't feel comfortable about this yet, to be honest. So I think on a normal day, I would probably like test this way more. Let me, mm, but today I'm a little lazy, so I'm just gonna submit it and see what the edge cases are. Um, okay, well, sometimes your best laid plans get foiled by it being accepted on the first try. Um, hmm. Okay. Oh, can I be a little bit faster performance-wise? This is pretty slow, actually. And usually I don't care about bit slowness, but that is literally the this prompt. Hmm. This should be logarithmic. Let me see. I mean, we could check whether like things went down or to the right. On the search, and everything else is kind of the same for that reason. I don't really use anything heavy. Everything of while loops. And that's the only thing I could think is if I don't do anything in login. How does this look performance-wise? I mean, okay, maybe I'm a little bit slower, but not that much. Other than people that are really fast. Like I don't think I'm like an O and slower. Maybe I'm just I don't know, have a lot of weird conditioning. But I feel like it's either that or dysfunction is so often I have too many levels or too few levels. Something like that. But well, the prints don't do anything, right? Or like I don't print. I mean, I have to. This is just the. Oops, I have to call this function for it to print. I don't think I call this anymore because I commented out. But yeah, that was actually my first start as well, to be honest. But that's why I was able to point it out pretty immediately. I mean, I guess I could be slightly better about it, but yeah, I think for now I'm not gonna worry about it. Maybe I'll look through the discussion. Let's look actually. Let's look at the discussion. See if I feel like C++ is so much faster. Two direction nodes. I mean, I don't think these. It's weird. Maybe I'll take a look later. I don't think any of these like changes how I did, except for maybe I could have done this with another pointer instead of allocating memory all the time. Maybe. But I don't think you could do better than looking at each of the subnodes. And none of my stuff is particularly slow that I could find. Because you need to do these, and in either case, most of these are just like a number of times, or maybe maybe a couple of these are just Python E things. Well, cool. Yeah, I mean, I think this is how long did it end up taking me? About 40 minutes. I mean, it's not great, but I think a lot of it was just under. A lot of this was just in the conception stage of me trying to figure out how to. Well, I think I spent like 10 minutes just reading up on some of these a little bit. But even yeah, I mean, first of all, I would not expect this on an interview. Maybe like work through different algorithms and stuff like this, but not the coding portion. This is a bit tricky. Maybe that's what I want to say. Well, I mean, it's not on a 45/1 hour phone interview, but yeah, I mean, I think that's something that we like. You could actually bring it up on an interview as well. It's like, well, for performance, I would probably like figure out the benchmark and stuff like this and figure it out. I mean, there's no way this is faster than, oh, sorry, there's no way this is slower than generating n coin flips, right? So I don't know. I mean, it could be, but I like it's faster than the alternative. I don't know how much more I could optimize. Maybe this is a little weird. Maybe that overfloats int in Python, so does some auto magic to longs. Maybe I should use 31. I don't know. But either way, these are like way minor things, and things that I would maybe think about. But okay, cool. But yeah, I wouldn't expect this on interview, at least not like this in a programming way. Maybe you get like some algorithm problems. Like, okay, let's say you have a skip list, you have all this stuff. Can you discuss about the properties? How do you do search? Why is it again? What is the worst case? Why is it only on average? And stuff like that. A lot of stuff that wouldn't even necessarily be based off you having to know this data structure before, because you could probably reason a lot of these. Maybe you wouldn't have a rigorous proof, but within an hour is probably reasonable. But overall, a fun problem to practice, because excuse me, you could implement most of this with a linked list. And I think if I implemented this another way, I would have implemented a linked list also from to the right and to the downwards. In that case, my traversals would look slightly different, but not that much. Only the while loops probably, to be honest, and maybe some weirdness like that. But